Hi everybody, I'm Mike and this is one of my latest projects here. I've entitled it Fun with Shift Registers. I'm using the 74HC595, which is an 8-bit serial to parallel shift register, and its main purpose in this little project here is to extend the IOs from my logic controller. You know, the more and more I get into programmable logic controllers, one of the first things that comes up is, well, how do you extend the I/O? And in this case, the shift register allows us to directly control 8 pins by using just 3 pins from our logic controller. We've got an input, a latch, and then a serial clock. Now the shift register, as well as having an input pin, also has an output pin. So by connecting the output to the input of the next pin, we can chain these together, and that's exactly what I've done. I've got 12 of them chained together. Now the last chip, its output pin comes all the way back around to here, which I'm not currently using this pin, but theoretically we could chain multiple of these displays together and drive as many as we want. Really the only limitation is how far you can push that input. I'm sure you'll get a little bit of signal attenuation as the distance from your logic controller increases, but you know, I haven't run up against any problems just yet. So I'm using the shift register to directly drive some 7-segment displays. Now, of course, there's a lot of different ways you can drive displays like this. One is to use, you know, probably a purpose-built IC, and that would be the best. Probably the best solution, especially if you're mass producing them. The other way is to use a technique called multiplexing. So you would directly connect 8 pins from your logic controller to each of the LEDs in your display, and then using maybe a transistor, you would briefly switch on and then off each segment in series. And through perceived vision, your eye would perceive that as being on continuously. A couple reasons why the 74HC595 is better in this circumstance is one, well, those purpose-built ICs are pretty expensive. You know, maybe $10 to drive this many displays. If you're like me and you order these shift registers in quantities of 100, you can get them for $0.25 a piece, so it's really hard to beat that. And as far as multiplexing goes, you know, your logic controller has to continually update that signal. So if your logic controller either isn't fast enough, or if you're running, you know, some complicated code on it, your LEDs will get dimmer and dimmer, and you may actually start to see flicker in there. And I've never had good results trying to drive this many LEDs using multiplexing. Another advantage of the shift register is each pin can put out, I think it's something like 35 milliamps per pin, as opposed to your logic controller, which, you know, if you have a good one, maybe it's 20 milliamps per pin and maybe something like 200 milliamps across all the pins. So the danger is if you accidentally pull too much current, you could easily, you know, burn out your logic controller, which might set you back 20 or 30 bucks. If you accidentally burn out one of these shift registers, again, you're only out 25 cents. So without further ado, why don't we see how it works? I've written a little test code here. I'm using a Q-Block CB280 as the logic controller and their little study board. It's kind of a nice development environment, especially if you're just getting started with logic controllers. You can write all your code in BASIC. But this sort of technique will work with just about any programmable logic controller on the market. So when I first turn it on, it just runs through a quick little loop and tests all the segments in the display. And then it goes on to another endless loop, and all I'm doing in this loop is just incrementing a variable, converting that variable to a string array, and that string array gets outputted to the display. And I'm just continuously doing that over and over just to see how fast it can be done, and we can, you know, visually see how fast it's running through that loop. So kind of a fun little debugging tool. If we're trying to optimize maybe a section of our code, we could hook this up and visually see how fast it's looping through. So kind of a fun little project. You could use it for a lot of things, maybe displaying date and time, or maybe coordinates off a GPS. That might be an interesting use. Don't worry about that last 2 segments. I'm actually using a long data type So, and there's only 10 significant digits, so I just turned the last 2 off since they're not needed. You know, if you're interested in building this project, I've got the source code, schematics, and a parts list available on my website, wilsonmj.net. Thanks for watching.